The 2026 FIFA World Cup. 48 nations, 104 matches, 16 stadiums. But here's what nobody's talking about. These aren't just venues, they are engineering experiments, each one solving a different, almost impossible problem. One stadium holds a Guinness World Record for the loudest sound ever recorded at a sporting event. One cost $5.5 billion, and engineers had to physically rip out the walls just to fit a football pitch inside. One stadium's roof is visible from a plane at 10,000 feet. And one arena has been hosting World Cup football since 1970, and it just came back from a 665-day full rebuild. I'm going to take you inside all 16. Let's go. We start on the West Coast. 4 venues, completely different engineering philosophies. BC Place, Vancouver. Capacity, 54,500. This is Canada's football moment. The country's first ever Men's World Cup is being played here. But what makes this building unique is what sits above you. BC Place originally opened with the largest air-supported dome in North America. That means the entire roof was held up by nothing but pressurized air. Essentially, the building was inflated like a giant balloon. In 2011, engineers replaced that system with a modern, retractable roof. But the legacy of that original pressure dome design still defines the structure's dimensions today. Engineering note: converting from a fixed pneumatic roof to a cable-supported retractable system without demolishing the existing concrete bowl is an extremely complex structural intervention. Seattle, Lumen Field. Capacity approximately 68,000. This stadium is notorious for one thing among engineers: noise concentration. The roof structure, partially enclosed on 3 sides, acts as a parabolic reflector. Sound doesn't escape. It bounces back onto the field. NFL players have described playing here as disorienting. The crowd becomes a structural element. Levi's Stadium, Santa Clara. Capacity, 68,500. Silicon Valley built a stadium, and it shows. This venue was designed from day one as a smart building. 5G infrastructure embedded in every section, a green roof garden that reduces thermal load, and a solar panel system that generates more electricity than the stadium consumes on event days. Levi's Stadium is, energy-wise, net positive. That's exceptionally rare for a venue this size. And then there's Los Angeles, SoFi Stadium, $5.5 billion. The most expensive stadium ever built on Earth. But here's the problem FIFA handed the engineers. The NFL field inside this building is too narrow for football. FIFA requires a pitch exactly 105 by 68 meters. SoFi Stadium's NFL configuration was about 4 meters too tight. The solution? Remove over 400 seats from the corner sections, physically dismantle part of the structure, and then grow real grass inside a semi-sealed building with no direct sunlight. The engineers installed a vacuum ventilation system beneath the pitch. HVAC units regulate temperature across the playing surface. Giant LED grow lights shipped in from the Netherlands simulate sunlight 18 hours a day. And above all of that, suspended 122 feet in the air, hangs the Samsung Infinity Screen. 70,000 square feet, 80 million pixels, the largest video display of any stadium on the planet. Its brightness is strong enough to be visible through the translucent ETFE roof, from aircraft descending into LAX. SoFi Stadium isn't just a venue. It's the most complex temporary engineering transformation in World Cup history. Guadalajara, Estadio Akron. Capacity, 49,850. Look at this building from the outside. The exterior cladding was deliberately designed to mimic volcanic rock, a tribute to the region's geological landscape. Those panels are not standard concrete or steel. They use a specialized textured composite system to achieve the visual weight of volcanic basalt while keeping the structure lightweight. Mexican fans call it the volcano. Engineers call it a facade engineering challenge.
Monterrey.
Estadio BBVA. Capacity 51,000. Nickname El Gigante de Acero, the Steel Giant. This stadium is positioned with surgical precision. The main grandstand opens to a direct sightline of the Cerro de la Silla mountain. That wasn't accidental. The architects oriented the entire structure so the mountain becomes the backdrop for the main camera angle. Every broadcast shot from Monterrey will have a 1,800-meter mountain in the frame. That is not engineering. That is landscape architecture as stadium branding. Mexico City. Estadio Azteca. Capacity 87,500. This stadium first hosted a World Cup in 1970. Then again in 1986, the year Diego Maradona scored both the hand of God and the goal of the century on this pitch. In 2026, it becomes the first stadium in history to host 3 World Cups. But it almost didn't make it. In May 2024, Azteca closed entirely for what became a 665-day full renovation. Engineers had to modernize a 60-year-old structure to FIFA's current technical standards. Better sightlines, new drainage, updated broadcast infrastructure, while preserving the historic architecture. It reopened on March 28, 2026, just in time. It hosts the tournament opener, Mexico versus South Africa, June 11th. Kansas City. Arrowhead Stadium. Capacity 76,416. This building holds a Guinness World Record. 142.2 decibels. That is louder than a jet engine at takeoff. Louder than a military aircraft at close range. It is the loudest crowd noise ever officially recorded at any sporting event, anywhere in the world. And it was engineered to be that way, deliberately. When architect Charles Deaton designed this stadium in 1972, he rejected the standard circular bowl that every other stadium was building. His reasoning was simple. Humans are not angular. Instead, he designed organic, asymmetric curves that concentrate and redirect crowd noise downward, back onto the field. The steep upper deck follows what engineers call a clear line of sight strategy. Maximum sightline quality at maximum acoustic impact. It opened in 1972 and is the oldest venue at this World Cup. It may also be the most alive. Houston. NRG Stadium. Capacity 72,220. This was the first NFL stadium ever built with a retractable roof, back in 2002. The 4-acre canopy opens and closes in under 7 minutes. But for the World Cup, that roof created an engineering problem. No direct sunlight, no natural grass. The solution arrived in refrigerated trucks from Denver, Colorado, where the Tahoma 31 Kentucky bluegrass had been growing for 18 months specifically for this tournament. 81,000 square feet of grass laid in engineered layers, drainage, stability matrix, temperature control. And to keep it alive under a closed roof, LED grow lights shipped directly from the Netherlands, running up to 18 hours a day. After the last match, the entire pitch will be removed in under 2 weeks. The NFL comes back. The whole installation is temporary. The engineering is anything but. Toronto. BMO Field. Capacity 45,736. The smallest venue in this World Cup, but arguably the most meaningful to a nation. This is Canada's first ever Men's World Cup match on home soil. The stadium was expanded specifically for this tournament. Additional seating rings integrated around an existing MLS scale venue. Structural engineers had to thread new load-bearing elements through an already standing building without pausing normal operations. Small stadium, enormous history. Gillette Stadium, Foxborough, Massachusetts. Capacity 65,878. And now, something you have never seen at any football stadium on Earth. Look behind that goal. That is a lighthouse. 218 feet tall, full 360-degree observation deck, built as a permanent structural feature of the stadium. There is also a bridge spanning behind the northern end, part of the same architectural concept. Architect Populus designed this as a deliberate statement about New England maritime identity. It is pure architectural theater. But from an engineering standpoint, integrating a 218-foot vertical tower into a stadium's lateral load system without compromising the seating bowl geometry took serious structural calculation. Philadelphia, Lincoln Financial Field. Capacity 69,000. The most transit-accessible stadium in this entire World Cup, ranked #1 across all 16 venues for public transport connectivity. From a systems engineering perspective, that matters. Moving 70,000 people in and out of a venue safely and efficiently is a logistics problem as much as an architectural one. Philadelphia solved it better than anyone. Hard Rock Stadium, Miami. Capacity 65,326. One of the few venues that required no grass conversion. The natural Bermuda grass already in place met FIFA standards. This stadium hosts the World Cup Bronze Final. But for most of the year, it also hosts Formula One. The Miami Grand Prix circuit runs around and through the stadium complex. When you see the track layout, you realize just how much multi-sport infrastructure engineering went into this site.
Atlanta, Mercedes-Benz Stadium. Capacity 74,295. Two things define this building as an engineering landmark. First, the halo board, a 360-degree continuous LED ring, 58 feet tall, running the entire circumference of the stadium's interior. One seamless display. No seam, no break, no interruption. At the time of installation, the largest LED display in the world. Second, the roof. 8 triangular panels open and close like a camera aperture or the iris of an eye. The engineering required each panel to travel along a curved track simultaneously, without any of them binding or misaligning. This stadium also operates on 100% renewable energy, with over 4,000 solar panels on site. It hosts a World Cup semi-final, and it deserves the stage. MetLife Stadium, East Rutherford, New Jersey. Capacity 82,500. The World Cup final is here, July 19, 2026. And the grass that players will walk onto for that final? It started growing 10 months ago at a farm outside Charlotte, North Carolina. FIFA's pitch team selected Tahoma 31 Bermuda grass after nearly a decade of research across 16 different climate zones. The sod traveled north in 20 refrigerated trucks. Beneath the surface, 2 feet of engineered sand, a full irrigation network, and a vacuum ventilation system. HVAC units regulate temperature across the entire pitch during the growth phase. A specialized stitching machine welds individual grass sections into one continuous surface. This is not laying turf. This is building a precision-engineered playing system designed to perform at the highest possible level on the most watched day in football. Dallas, AT&T Stadium. Capacity 94,000. The largest venue in this World Cup, and the host of 9 matches, more than any other stadium. The engineers who built this had one goal: the largest enclosed structure on Earth. They delivered. The roof is held by 2 arched box trusses, each spanning 1,225 feet. That is the longest single-span arch on any building anywhere in the world. Each arch required 14,100 tons of structural steel. The forces involved reach 19 million pounds. The retractable roof opens in 12 minutes. Hanging at 90 feet above the field is a video board that, when installed, was the largest in any stadium on Earth. 160 feet long, 72 feet tall, weighing 1.2 million pounds. And the nickname? The Death Star. Look at it from the air. You'll understand why. 16 stadiums, 3 countries, 1 tournament. From a 1970s concrete bowl in Missouri that engineers shaped to channel sound like a weapon, to a $5.5 billion building in Los Angeles, where engineers grew grass under artificial sunlight inside a sealed arena. From Mexico City's Azteca, carrying 60 years of football history into its 3rd World Cup, to a $10 billion grass-growing operation that shipped turf in refrigerated trucks across an entire continent. What FIFA built for 2026 is more than a football tournament. It is the most ambitious stadium engineering project in history, and the matches haven't even started yet. If you want deep dives into individual stadiums, the physics, the materials, the exact engineering decisions that went into each one, subscribe. We're going inside each of these buildings one by one. See you on the next one.